Okay, and we're on. So, hi everyone. Super excited for this meeting. This is the Web Performance Working Group talking to the web performance community at large about A/B testing and how we can improve it. Personally, I've been thinking a bit about this problem space a few weeks ago and realized that there's um, a lot of misunderstanding between the web performance community and the A/B testing community. And overall, we all have very common goals. We all want to make sites faster and better for our users. So I thought we should talk about this and try to figure out a solution. So we have a very tight schedule today. We have 4 talks by Tim Kadlec and Melissa Mitchell about the performance issues that they see in the wild in real sites today. And then talks from Grishma from Optimizely and Dmitris from Google Optimize about how current client-side A/B testing frameworks work. I will also present a short, not really a proposal, but something I've been thinking about that could lead us the way towards some sort of a solution. And then I thought we can devote an hour and 15 minutes or more or less to brainstorming to talk about all that and try to figure out the best way forward to make things faster. Okay, and so I think we can get started with the presentations shortly, but just a small note beforehand. This meeting is being recorded and will be posted online. We will be taking minutes in the agenda. And as all working group meetings, this meeting is under the W3C's CPC, the Code of Ethics and Professional Conduct. So yeah, you can go read that. I will post a link, but in short, let's just all be professional and conduct towards others in ways that we want them to behave towards us. And with that, I think we can get started with the talks. Tim Kadlec, are you around? Can you share your screen?
I am. Yeah, I'm here.
Cool. So can you share your slide, or you shared a link, but do you want to present? Yes.
Yeah,
awesome.
I think it's coming up here in a second.
Yes.
Can everybody see it now? Sweet. Okay. So my name is Tim Kadlec. Just like 10-second overview for those who don't know. I work now on web page test at Catchpoint. And I've only been doing that since I think I joined right before the Christmas holiday. So prior to that, I was doing performance consulting, which is where more of this stuff is coming from, is, you know, things that I was seeing. And hopefully this ends up being a decent like queue up to tee up for some of the other stuff coming up. So just at a high level, just to sort of level set a little bit, client-side A/B testing works typically by you're providing some JavaScript down to the browser. That JavaScript is then going to manipulate the document object model or the CSS object model or both to apply one or more experiments to the page. As you would expect, any time that we're doing something like this, we're manipulating DOM or CSS object model, we want to make sure that we're avoiding shifts or flickering of content, because that's always a risk anytime any of that stuff is changing. It can be disruptive to the user experience. But also in the case of A/B testing, you know, if somebody's seeing like the, you know, case A and then B snaps in on top, or, you know, whatever that situation happens to be, that could potentially mess with the results. So the challenge here for A/B providers is that they have to find a way to combat this. How do we reliably get down A/B experiments down to the browser, get them executed, get the DOM and CSS object model set up as efficiently as possible in a way that they can ensure that that flickering or shifting or fluttering or however you want to call it doesn't actually occur. The easiest option is to drop in a synchronous script, and this is what you'll see very often. I know this is what Optimizely uses. With the synchronous script is probably easiest from an implementation perspective, both from a provider and for the developers themselves. It's literally just drop the script in and you go. The advantage of this from the simplicity perspective is that in addition to being one line of code, it gets that higher priority on the network, and that execution is guaranteed to happen right away. So conveniently, from an A/B perspective, at least, this blocks the page from displaying until those experiments have been applied. We know that there's going to be no flickering, no shifting of content. They're just going to see the experiments that they should see, nothing else. However, this does mean that from a performance perspective, as a site owner, we've now moved that entire third-party connection into our critical path. So in this example, this is Ultra Mobile. They're running Optimizely. This is on a 3G fast connection. There's 2.3 seconds that we're spending here making that connection off to Optimizely and then downloading that content. And the entire time that 2.3 seconds is occurring, the page is blocked. Like, that's all we're going to get out of it. This is a Chrome profile from the same trace, from the same web page test run. So at the very left, the little blue marker, that's where we're parsing the HTML lines 0 through 6. And you can see there that that's where it finds Optimizely's script, and that kicks off the request up above. Once the script has arrived, there's this execution chunk. And then right after that, that final little blue tab off to the right there, that's when HTML parsing picks back up again. So that entire time, that 2.3 seconds plus execution, in this case, was around 800 milliseconds or so, the HTML parsing is completely paused. So we've introduced a significant bottleneck into the page of the actual page. This is a risk for any site owner, both because, any delay in terms of getting content out and that first paint out is significant. Anecdotally, just from, the folks that I've worked with, one of the most predictable correlations that there is between that first paint start render and some sort of a business metric. Pretty much everybody I was working with would see a connection either between engagement or conversion rate with that particular performance metric. So pushing it out 2.5 seconds is not ideal. It also introduces a single point of failure risk. If that third-party provider is to hang or to take a long time to respond or completely go down, we've now introduced a situation where we're potentially breaking the site entirely because of our dependency on that third party. This is a web page test run showing single point of failure situation where Optimizely, we just tell it not to respond, just to hang. And you can see we've got a pretty dramatic difference because then we're up against browser defaults in terms of timing out those requests and things like that. Now, there's a lot more.
Quick question on that, maybe for after the discussion. I would like to know if anyone has data on how often this happens, because that's an issue, but I would like to know how big of an issue it is, maybe in the discussion later.
Yep, that's a good side. It would be a great thing to see as well. We looked at this a little bit when I was at Akamai, but boy, I don't remember what the results were for that. And that's been a few years too at this point. As an aside, there's more issues that come across from pulling things in from a third-party service provider for recommended reading on that. Harry wrote a really good post, I guess a couple years ago. It doesn't feel like it was that long, about self-hosting versus third-party domains, which gets into things around network prioritization and stuff like that as well. So the synchronous script, we have this problem where we've introduced this bottleneck in our critical path. So an alternative approach that you see a lot of A/B providers do is an asynchronous script. This mitigates our single point of failure risk. It moves the third-party connection from that critical path. But now what happens is because it's an asynchronous script, now theoretically the page could be displayed before those experiments are applied. So now we risk introducing that shift or that flicker. And so typically when we see A/B providers use an asynchronous script or offer an asynchronous script, it comes paired with some bit of CSS, some sort of an anti-flicker snippet that typically hides the page by setting opacity or something like that until those experiments have a chance to run. Now, this introduces its own level of risk. Harry found a thing around Black Friday, apparently, where he went to a retailer and the entire site was blank because the CSS was applied to hide the visibility and set the opacity to 0, but the JavaScript never loaded. This is an exception, I would say, to the normal case. Most providers, any responsible provider, is providing some sort of a timeout as well as part of that snippet. So this is the Google Optimize default snippet, and you can see down here they're setting a 4-second timeout. So in their case, if they hide the page, you're setting opacity to be 0, they try to load in their experiments and scripts and stuff as they need to. If that stuff doesn't come in within that 4-second timeout window, then the page will be displayed again and the experiments won't run. That way, again, you still avoid the flickering stuff. Now, the defaults for each of these services differ. Google Optimize was about 4 seconds. Adobe Target is 3 seconds. Visual Web Optimizer, 2.5 seconds. Each of these can be adjusted in the snippet. You can bump this up and down as you want. I've worked with a lot of folks using Shopify, and Google Optimize is extremely popular with the Shopify folks because with Shopify, it's much easier to have client-side experimentation than something elsewhere, right? Because of the way the platform works. And Google Optimize is typical. So one of the things we'll often do is sort of adjust this timeout up or down as necessary, typically measuring how often we're timing out and seeing what we need to do there. These timeouts should sound high to anybody who's like focused on performance, because they kind of are, right? Like if you think about it, we're saying Google Optimize, we're giving you permission to block display of the page for up to 4 seconds. For 4 seconds or so, like pushing out start render is a significant hit in terms of performance. So these are high defaults, but they kind of have to be, because moving these requests out of the critical path does come with risk from an A/B experimentation perspective. Asynchronous scripts get that lower priority. In Chrome, what that means is that they get moved to that second loading phase. So Chrome has this layout blocking phase, right, where it's prioritizing head resources and only loading stuff, below that and from the body, like one at a time. Well, that second phase ends up pushing all those other resources out. So any asynchronous script gets scheduled in that second phase. It's now contending with all of these other page resources for bandwidth. So it's going to arrive a little slower anyway, and in addition to just being queued up much later. This is an example that Andy Davies was kind enough to offer up for me from Plums. You can see here on request number 25 in this case is the request for Visual Web Optimizer. It's an asynchronous script, so it's get that lower priority. You can see it sort of falling on that second half of the stair step here of the waterfall. And it's contending with all these other resources for bandwidth. As a side note, he also noted that Visual Web Optimizer is actually uncacheable. It turns out that they're generating like a unique script for each and every page, and a random number is a query parameter to the request, so you can't actually cache it either. So in the result of this case, because it arrives so late and because it's queued up so late, we actually have the situation where the page is hidden for 2 seconds until that script arrives and gets a chance to execute. What's interesting to me, and one of the things that I've seen with some folks that I've worked with, is that this can be a little tricky to catch down depending on how you're looking in your analytics. Here's a web page test run. You look at the first spot here, there's that thin green line, and that lines up here right up at the top of the film strip. You can see that the page is blank. That's actually when first contentful paint is firing in this case, because what's happened is we've set opacity to 0. It's technically still there. It's just you can't see it. So if you're looking at real user monitoring, you're going to see your first paint and everything looks great. It's only actually when you look at something synthetically here that queues up that start render to be much later over here to the right that you see there's a bit of a discrepancy between the two metrics. I ran into this with, again, one of the Shopify, or often I guess with a few Shopify folks that were using Google Optimize, where they looked at their real user monitoring and everything looked great. And it was only once we started diving into film strips and web page tests and speed curve where they were using it, that we could see that there was an actual problem here. The situation actually gets worse if a site is using a tag manager to handle any of these loading of the experiments. Now, this is, to their credit, this is what I think a lot of A/B providers kind of warn against this, particularly if you're using it in conjunction with an anti-flicker snippet. But this was one audit I did where it was the 86th request on the page was the one that actually brought back the disabled the asynchronous anti-flicker snippet part. So until this request arrived and the JavaScript executed, the page would be hidden. So basically for this particular person or this particular site, they were reaching their Google optimized timeout of, I think they had bumped it to 5 seconds as well. They were reaching that timeout probably 30% of the time, somewhere right around there, when we actually started to monitor to see like how often that was getting tripped. And it was because they were using Google Tag Manager to pull it in, and it was happening so late in the waterfall. More recommended reading on anti-flicker snippets. I think Melissa noted this in her document as well that she had put for reading material, but Andy wrote a great post on anti-flicker snippets if you want to dig into that a little bit. And he spends a little bit more time on like how you might monitor when those things are timing out and how. So we've talked about getting the code down to the browser, but now we've got this whole process of what happens after that fact. A single snippet can include many events. Different pages and experiments kind of all get lumped together in one snippet by default, typically. In my experience, those experiments have a tendency to linger on. I've worked with a lot of organizations who couldn't tell you, like, you know, which experiments happen to be running or who put them there. And often they find that there are things that are running that they didn't realize were still like in play. Now I understand that that's not a technical problem. That's you know, an organizational issue, but it is something that I've run into often enough to tell me that it's, you know, something that's significant, a significant challenge that pops up. The more of those that you have, the bigger the amount of code. The other challenge here is that a lot of these experiments tend to be pretty inefficiently written. So they're doing DOM manipulation in a very inefficient way, which again prolongs that execution cost. So all of this code adds up very quickly. This was the Ultra Mobile example where they were pulling in about just under, you know, 0.5 MB here of uncompressed JavaScript code. And so very typically we see this manifest itself in long tasks. That stuff is expensive. Yep, fire away.
Tim, I had to rush you, but I'm rushing you. So
yeah,
can you...
I'm almost there. I'll zip through. Thanks, sir. So the observing the DOM can be really expensive, especially when it's on a constrained mobile device. These long tasks can be obnoxious. So it's, in my opinion, the perfect marriage of third-party risk and JavaScript bottlenecks. I'm not going to spend a lot of time on the why we use it because I think some of that gets queued up in Melissa's. But you know, we have issues where the data may only be available on the client, not actually available prior to that because maybe they're relying on other third parties. Some organizations can be using it for other things besides experiments because of its ease of deploying. It can be workarounds for development backlogs, bug fixes, etc. There's a perceived cost. You know, the cost of using client-side A/B experimentation can be more affordable than server-side solutions, although as I've worked with organizations, we've seen that you have to factor in the potential dip in revenue from the performance overhead. This is a small example, but one of the organizations I worked with, we were looking at several $100,000 in lost revenue because of the performance hit. And then simplicity. Client-side A/B tests are easier in most cases to deploy. You have WYSIWYG editors. It enables marketing to try out new experiments, and it detaches it from that developer workflow. So that's the high-level overview. I think, like I said, it looked like there's a little bit more that I think each talk is going to go into in depth. So thanks.
Thank you. Melissa, can you share
your screen? All right, I will go ahead and present. I'm going a little bit more into that process sort of thing, and like, why are we seeing these problems? And like, what does it look like from a Core Web Vitals perspective? So for a little bit of background, my name is Melissa Mitchell. I am a web ecosystem consultant for Google, which means my day-to-day job is working with site owners to try to help them meet Core Web Vitals one-on-one and really getting that in-depth feedback on what they're struggling with and to highlight those struggles internally and to talk about them. And universally, when clients are working towards getting towards Core Web Vitals, client-side A/B testing almost always comes up, regardless of whether it's retail or insurance, baking, content publishing. A/B testing is pretty much universal in one of the struggles that they're working around in meeting these Core Web Vitals. So real-life examples, just to go through to kind of level set. I will speed through this a little bit since Tim gave a great explanation of what's going on here. Technically, as an example, Zales.com, they're using an A/B testing library maximizer This is an AMP PWA, and this is a hard load, so we're having a hard load SPA without the AMP load into it. And so this is a little bit more janky than the real user experience, but it still stresses the point of how much an A/B testing library can actually affect the user experience. So we are seeing FCP increased by about 4 seconds, so we're likely hitting that timeout right there. And then we're also seeing LCP delayed by a second as well. This is concerning for Core Web Vitals as they're working on this because FCP is a lower bound for LCP, and if we're stuck at the 4 seconds, there's almost no way to get out of that poor category. Similarly, cumulative layout shift, we see a shift of 0.17 that comes just from this testing library. And a lot of that is coming from adding experiments onto the page and shifting the elements around to make it fit. Underneath, I have also added the RUM data from the Chrome User Experience Report for what the real user experiences are like based on these synthetic. And we can see that that timing would make a difference for these Core Web Vitals here as they're working and going through this. Another example, and I think this is on a slightly opposite spectrum, this is more like best case scenario for out of the box A/B testing when we're seeing it out in the wild and in real life. This is from npr.org. They do use a React single page application. They are not on AMP. And with their A/B testing, they're seeing about a second impact on their web pages. And now this is important because it is the last piece. LCP is the last piece for meeting Core Web Vitals here. And they're right on that edge. Currently, they're at 3.2 seconds. And so that roughly second that A/B testing library is taking up is a factor in them being able to meet those Core Web Vital thresholds. So why are we seeing these challenges? And I can't stress enough that I feel like the strongest challenge is that the primary A/B test creators are not in technical roles. They were not hired for their coding experience. They're using what you see is what you get editors, and they're typically completely unaware of the performance impact that their work can have on the site and then on the business KPIs afterwards, and including Core Web Vitals and others. And as Tim mentioned, they will use A/B testing libraries often to bypass a lot of the internal bureaucracies between their departments and the IT and engineering orgs. Tim mentioned the Redger blocking JavaScripts, the anti-flicker snippets. So we will probably just more dive right into the server-side A/B testing, and that it just doesn't meet the business requirements, because even though that helps and we have a technical solution that could do the initial use case for A/B testing, it doesn't help with all of the other things that A/B testing is actually used as a band-aid for. So before I jump into that, there is a universal truth, which I've learned as a developer. Users are never going to use your software the way you intend. It's just a fact of life, and you end up supporting use cases you never knew existed. And a corollary to that is sometimes your users aren't even who you think and who you intended them to be. And so that's something I usually keep in mind as we're going in with the A/B testing, is they get very creative about these. So what are the business use cases? What do business users, when I meet with them, and why are we still with client-side testing? What are they saying? The first reason, and this is the most obvious, we want to increase conversions and revenues, and this A/B testing is essential for our business. And that's usually what you're going to see, and server-side can do this just as well as client-side. So this isn't the reason why we're not switching over to the more performant solution. Well, another thing that A/B testing libraries do that are client-side is that they reduce the workload on marketing teams. And again, I can't stress this enough, they usually are not technical. So if they do code, it's probably not what they were primarily went to school for. They are not computer science graduates. So if they do code, and that's usually not the case, it's usually self-taught and they're trying to just get it done. On number 3, a lot of these companies outsource their web development. And so there is not only the additional bureaucracy of having to go in between departments, you then have to file tickets with vendors, and then you have to prioritize the costs, and then you have to work out all of the bugs with them in order to get it there. And so it becomes a lot more expensive, especially if you're outsourcing that web development, to add additional engineering requirements. Number 4 is super important. It allows tests to be independent of release cycles. This is critical for the business side because most companies can be fairly slow with their release cycles. Lucky if we see every 2 weeks, every 2 months is not uncommon. And that's just not agile enough if a CEO comes down and says, I want to change X tomorrow. And oftentimes businesses will use the A/B testing to adjust to this. We saw this a lot during COVID, where hours and banners and whatnot were put in through A/B testing libraries to communicate important updates with the COVID situation, rather than putting it in through code. One example here, one of my, someone I worked with, they had services that were only in store. And when all the locations shut down, they wanted to move quickly to offering similar services on the web, but because they're outsourced most of their web development, they actually implemented the whole solution within their A/B testing library instead of going through the initial pain of trying to work it out with their vendors before getting it in there, because they had to be more flexible that way. I know we're running short on time, so I will keep this short. Successful tests can be kept in live until development work is done. That's a lot of what Tim was saying. These will hang around forever. You also get to avoid excess design work for tests. If you've ever worked for a company that does waterfall or agile design work, you know that there can be extra burden if an IT department absolutely insists on having 10 pages of documents for one line of code. It can also double as personalization. Many A/B testing libraries do offer that sort of service. And so having that library in there, it gets tied into that. And last, you avoid tech debt. A lot of A/B tests, I think it's roughly around 70%, are either unsuccessful or unconclusive. And this way you are not putting those failed tests or bloating your CSS or your code off of those failed tests. And so there's a lot of these business reasons that we need to keep in mind, that the client-side A/B testing library is solving these pain points that the current solutions that we have to work around the performance issues aren't yet addressing. So happy to answer questions, and yeah, I will pass it back to you, Yoav.
Awesome, thank you. So yeah, lively discussion in the chat. I think that, do we want to spend 5 minutes on questions before moving over to the A/B providers side of things? Good. I think that
happy to answer questions. I just couldn't see the chat while I was presenting. So if there are questions there, yeah, I'd be happy to answer.
So one question from Alex is, I may be naive, but isn't the obvious solution to all of this is to just serve either content A or content B from the first party and eliminate all the third-party timeout delay?
Well, I'm not quite sure I'm following what that solution would look like, right? Because when you're on the website, is this person in group A or group B, right? And so how are you deciding at that point? So you still need to have some JavaScript to decide what group is this person in. The A/B testing library, people can chime in here. I am not an expert in how these things are actually written, mostly on working around them to try to meet core web vitals. So I will let someone else chime in on whether or not making it first party could actually help.
So I don't know if, like for Alex, were you talking about basically just like, you know, your version of like you're doing server side? I mean, like the first party is responsible for providing both the different test A to one set of users, test B to another, whether that's driven by the server or that's JavaScript that's, you know, manipulating, but it's all self-hosted. Like, is that what you were driving at?
Well, when I used to scrape data from websites a long time ago, which I officially don't do anymore, I noticed that there were several websites that I was interested in their data of that would respond with very clearly either website A or website B if there is no cookie. And I'm just thinking that that is how A/B testing could be done without any of this third-party script loading stuff and timeout of 4 seconds. And I wonder why we're not trying to push people towards that model instead of just making it more convenient for third-party A/B testing stuff.
Melissa, I think you had a bunch of ideas that kind of were around that, if you want to.
Yeah. So if you have to have page A and page B written, then you're requiring engineering resources to write those pages. The groups and the teams doing these tests are not really engineers. And to get this, they have to request that resource from the engineering department, which may or may not be prioritized and certainly isn't going to happen fast enough in the time that they need to do these tests. So that would require actually writing out both pages.
Okay, well, I mean, it may not be common, but I have seen it. And that's just what I wanted to say.
I think the other thing is many people are using platforms that just don't support it. You know, using Demandware or e-commerce platform off the shelf or a publishing platform off the shelf, they just have no concept of experimentation built into them.
And Kenji's point is good too, is it has to be free or cheap enough. Like there's always a cost benefit analysis when it comes to these things.
Okay. Cool. So I think that with that, we can move over to the A/B testing framework side. Grishma, do you want to share your screen?
Sure. So hi, my name is Grishma. I'm from Optimizely. So I'm here to present about Optimizely, how Optimizely does client-side A/B testing. I'll skim over the first few slides because both Tim and Melissa have covered it exhaustively. Like some of the advantages is it's easy to implement, easy for non-engineers to get into, faster iteration. And another useful thing is short-lived experiments where it is time sensitive. Like for one example, when Black Lives Matter protests were happening, Optimizely put up a banner. That's a short-lived experiment, and that can be done much faster without any engineering input. So that's some of the advantages of client-side A/B testing. I'll skim over this because I think it's been covered different types. One thing Optimizely also does is personalization. So this is where it gets more complex with regards to server-side testing. Like you use a lot of third-party integrations. Like if somebody has visited Google, then do this. If somebody is from Microsoft, as in this example, present this. If somebody has visited this page twice, on the third time, show them a different view. So these kind of examples make it harder when it comes to doing something server-side. It's rendering itself. So personalization is its own case. So when it comes to client-side A/B testing, some of the key constraints is like it has to preserve user experience. We talked about flashing, flicker, how it can ruin the user experience, but can also undermine the integrity of experimentation results. Further, like if you want to modularize the JavaScript, you have to make sure that you can only do so such that you don't rely on it being executed at a specific point. Anything you inject from within a JavaScript will happen asynchronously, and it's out of control from a vendor perspective. Like Optimizely cannot assume when an asynchronous script will execute. So we are limited by how much JavaScript we can push asynchronously. And the other constraint is like most of our customers don't want to deal with a lot of nitty-gritty details. So they don't want to deal with which cookies to pass, what to pass to us. So as a vendor, we have to be able to deliver this completely independent of where the visitor is coming from, what site they are on, which geolocation it is. So this is all taken from the client side, and we cannot assume anything about the visitor or the customer. So here's a list of few things that we use as client-side attributes for deciding which experiment to show, which variation to show, who to show. So cookies, IP, geolocation, and some of the interesting parts come around like URL changes. This is for a SPA framework, for example. When you're using a SPA app, the first page loads, but as you navigate through the web page, the page itself does not load, but a customer can have an experiment executing specifically for a different navigated URL. And so this kind of information should also be within the third-party JavaScript, third-party client-side A/B testing to actually execute on this kind of information. Additionally, there are experiments that execute on certain DOM changes or a specific JS condition, like this particular element is present or this particular variable is defined. And we at Optimizely also rely on local storage for behavioral changes. If a person visited this web page twice, on the third time show something. So that's a behavioral change, and that kind of experiments and personalization changes rely on local storage. So how does Optimizely work? As Tim showed in the first example, it's a one JavaScript snippet that goes into the head of a customer's website. And this means the customer has to ask an engineer or IT to implement this once. And after that, it doesn't have to, nobody has to do anything. So typically marketing or growth teams are the ones who go and create these experiments, start running personalization campaigns. So they don't have to deal with the nitty details of how to implement it. So they use the WYSIWYG editor to make the changes, and this particular JavaScript has to update as and when they make the changes to not only include the code that is required to evaluate the changes, execute the changes, and track the data, but also includes the data upon which it's executing. So it has to have all the experiments that the customer has set up, all the variations, all the events that it needs to track. So all this information is in this one JavaScript, and as and when the customer does any changes, it goes back to the JavaScript and the JavaScript gets updated. So as mentioned before, there are performance challenges. We are very aware of it, very acutely aware of it. As a performance engineer, I've had to talk with a lot of customers about this. So some of the reasons is code necessary to do all this is not cheap. It's a very complicated piece of code, and it is huge. There are different types of changes, different types of experiments, different types of attributes we need to evaluate. So that's a lot. There can be any number of experiments. There are customers who have 5 experiments. There are customers who have 50 experiments. So it can range a lot, and each experiment can have its own set of variations. And the changes themselves can be very large, especially as non-engineers writing these changes. They're not the most optimized code. They can be very simple, but they take a lot of space. So the changes itself is huge. Synchronous JavaScript is obviously an issue. And the experiment data changes frequently, so the JavaScript snippet itself cannot be cached. So as we kept thinking about these challenges, and around 2 years back, Cloudflare announced its new product, Cloudflare Workers, and that was the perfect example for us, a perfect chance to actually improve our product. So we decided to use Cloudflare Workers, which is essentially serverless execution. So it's a JavaScript node at the edge. So we moved all this execution that was initially happening on the client side now onto the edge. So all the targeting, all the evaluation, everything is moved onto the CDN edge node. And because it's the edge node, it is much faster. It does not rely on how slow the browser is, how slow the device is. It happens much faster, and we only send to the client or the browser just the variations that needs to apply, just the minimal amount of JavaScript that needs to apply. So that means anything that relies on cookies, on the IP, on geolocation, device, browser, query parameters, URL, can all be done on the edge. There are still a few things that cannot be done on the edge, and these we do by injecting a follow-on snippet. So this is Optimize the Edge, which we released about a year ago. And the way this works is, it's again a JavaScript snippet in the head, but this time it's a first-party JavaScript snippet. The way customers implement it is either they target their CDN to fetch from our Cloudflare worker CDN, or you can set your DNS to get from optimizetheedge.com. Either way, it's a first-party JavaScript, so it can forward the cookies, it can forward all the important attributes that we want. And so the big difference is here the execution logic is all in the Cloudflare worker, and only the very minimal amount of JavaScript is sent to the browser. So that means what was 230 KB of JavaScript is now close to 5K, 10K range. And the execution takes less than 5 milliseconds because it's just doing very minimal JavaScript, like changing the color or whatever else the changes they have implemented. In addition, we inject a follow-on JavaScript snippet asynchronously. And this is what does the other important things, but are not as render blocking, like tracking all the events that need to be tracked, everything else that goes into determining the results of the experimentation, and SPA-related changes. Because in SPA world, you don't reload the pages. That means anytime you navigate, the URL changes. So in some sense, there might be new experiments to execute. And since you don't reload, you cannot go back to the edge to evaluate these. So SPA-related changes happen in the asynchronous snippet. As a result, most of the performance challenges go away. There are still a few. Synchronous JavaScript is still a problem, but so far we have seen the impact to be less than 50 milliseconds. Changes frequently, so the snippet cannot be cached. Hopefully 50 millisecond makes it that caching is not the biggest concern. There are other challenges, of course. There is security, and then the evolving browser framework ecosystems, which I assume is not the point of this talk. So I think that's it from me.
Thank you. Thank you so much. One question from Pat Minion is, do we have a sense for how much of the pain is coming from A/B testing library plus the data versus running the client-side code? And if it was all client-side by the same origin, we could, yeah, I don't know. Pat, do you wanna ask your question instead of me asking it for you?
Sure. I mean, basically, it's just trying to figure out where the source of the pain is. Like, obviously, there's a lot of tooling built around client-side A/B testing and flexibility, but serving from third-party origin was some of the pain, particularly around SPOF and scheduling and that kind of stuff. And the question was, if we can first-party serve and get it delivered quickly and cache and all of that kind of stuff, how much of the A/B testing pain goes away, or how much is still left because of how long it takes to run the code in the browser?
Yeah.
And do we have to solve both problems?
I think we have to solve both problems from my experience. It's not a first-party JavaScript or self-hosting does help to a certain extent. It does reduce the download time. But especially with mobile browsers, execution becomes a huge, like the client-side execution becomes the biggest reason why A/B tests thing becomes the problem. And because it does take a lot of time for our JavaScript code to evaluate. Some of our customers have about 100 experiments. So even if you put 1 millisecond per experiment, it's 100 milliseconds just to go over the list of experiments. And then there's a complication of how they define the experiments, what are the changes executed. So there is a huge problem even with the execution part, which is why Edge takes all of that out as well. And
well, it moves it, right? It moves it to the edge and delays the time to first byte, potentially.
But it, from our
But you're
data,
not running on a mobile device anymore.
You are, yeah, you're not running on a mobile device anymore, and you're moving it to a much, much faster system. So what would take 500 milliseconds to execute here is taking 40 milliseconds on an edge node. And even with that and the download time, because you're only sending 5K instead of 200K, download also gets faster. So like you are saving as a whole.
Thanks. Okay, so yeah, we should be moving to the next talk. So Dimitris, do you want to present?
Sure, yeah. Let me do that. So hi, my name is Dimitris Dimitropoulos, and I've been I'm going to represent here Google Optimize. I've been in this team for a period. And I'm going to maybe pass quickly, some of the slides I have, because I think have been covered by many other people. You all know A/B testing, and that this is, the set of tools that Google Optimize is also, in the same area. Google Optimize was basically launched recently in 2016, first as a premium tool, and later, a year later, it was launched for free with limits. And one thing to say here might be, not really covered a lot. At least Google Optimize is also providing what we call server-side experiments, a way to measure things unrelated with this whole topic that we are covering today, which is like DOM manipulation. But my rest of the slides are basically going to cover this client-side runtime. But there is also the part of the product that talks about that's about the statistical side of things, and there is a solution there. But basically, yeah, as everybody has said, it's the same story here. The widget is intuitive and easy. I also would like to stress here that, in my opinion, and I think you can see it from the interest out there, marketing efforts and UX improvement efforts do matter a lot, as equivalently to the performance of the site, because a good site with good content is also what users experience. So I think finding solutions to improve sites, even in things like marketing or user improvements, usability improvements, doesn't only is better for the sites and their conversions, but it's for the users, of course. That's the current use of Google Optimize that we've seen. As I said, a lot of appetite if you think that this is a relatively new offering. That's data that we get from BuildWith. That's a small slide that just reiterates how these tools work. At least the runtime, the DOM injection part of the product. This is where a marketer will use the editor to produce a bunch of changes in the current page that will all get in a script, which then will be served on the browser, and just before rendering, it will kind of try to change the page fast enough and and implement variants or personalizations. This is how the Google Optimized editor looks like. Not terribly, I wouldn't call it extremely user-like. It's very, easy to use for someone that doesn't know anything about web development, but as it has been covered, there is always a range of skills out there. People that are marketers have some experience with web, and they just want to have a tool that bypasses the bureaucracy and gets the job done. Targeting is something in these tools that also matters a lot, and I think others have covered that part. The URL is what's based in all experiments. It's an area where, unfortunately, we couldn't find easily ways to improve because sometimes, we kind of bundle all experiments in a single script. That has benefits as well because you get caching around as you navigate through the site. You can't trim the script easily, like you can't just get the experiments that are relevant to the page due to referrer policies from the third-party scripts. You can't even know sometimes what's the path, what's the page that the user is looking at. And also, as it was referred by others, there are SPA sites that are, a very different story. We also have audience targeting in Optimize, which is doing things like, what's the device that the user is. That's a very common one. And so, as you can imagine, and you probably know, like the abilities of a marketer to ask a developer, please, get that experience on, say, Geo is a good example, right? I want to have an experiment only in a particular city. It's easy to say, yes, we can do it that or this way, but I think in reality, out there in businesses, it's something that they value the flexibility and the easiness of doing that with a tool like that. And there is also the reason, because that question came around, why do we need to go to the client for some of the targeting? It's not terribly common, but very often there are signals that you only can get in the client. There's a lot of integration of systems that happens on the browser itself. In today's site, some sites will do recommendation, get recommendation services on the browser, even authentication sometimes. So, sometimes it's much more convenient to check on the client things like, is the user logged in? What is the, what my recommendation engine is providing as the content, and link all that as targeting of the experiment. Yeah, so as I said, users, the story here is that, users typically put a single snippet in their whole site, and that helps them doing experiments on different pages continuously, iteratively. The iteratively part is also something very important and something that's really hard for them to achieve, by going to their development cycles. Using Google Tag Manager, it was also mentioned. It's a very big thing we are seeing. People prefer the flexibility of adding, removing in experimentation on pages, or doing it in a subset of their site. As it was mentioned, again, it's a suboptimal situation because there is another asynchronous request that needs to happen. In Optimize, we try to guide users towards limiting what their experiments are. There are some limits there in the UI and in the final container script to make sure that we don't harm the sites. We have at least some limits in how much the sites can be affected. We kind of started trying to be more async in Google Optimize. We started by becoming a module of Google Analytics, and that was asynchronous. As it was mentioned, again, we now offer both a sync and an async, more simple separate script that makes implement installation very simple, that lots of problems and trouble was coming from problematic installations. And also that there is a better story now with Flickr more often, better performance, basically. I would like here to talk about the differentiation between the Flickr, which is like, the typical Flickr you can see in the page where there's a render, versus the wrong content. So what the statistical side of this project really cares a ton is the situation where a user sees the original content and that changes. Like you can imagine my title of my site says something, and after a second it changes to something else. That ruins completely the experiments and the results. So Optimize has some hiding once it loads to target content that may not have been parsed in the browser, because the script can load fast, but it can be added later. That's like targeting hiding, and that's a much better way to hide. But the problem is that we need to be in the page to do that. Before that, for the synchronous case, we had that anti-Flickr snippet that was mentioned that does opacity 0 the whole page. And we did it configurable and customizable, giving options to users to hide only the part of the page where they are doing experiments, so that at least the user will get some, the skeleton of the site, so that they have the experience that the site is interactive. And configure, you can configure timeouts. There's, as it was mentioned by Tim, there's a timeout for worst case. Yeah, and also recently, for some time, we've also been covering the SPA use cases. This is another area. And for SPAs, you would expect that this is going to be a much more trickier story because the page just builds itself, and you would hope to get more developer-oriented experimentation solution there. But unfortunately, still you have marketers that need to go and do small changes in these virtual pages in SPAs. Optimize is free, has limits for free users, up to 5 experiments. That's perhaps one of the reasons that you don't have a ton of things happening and a ton of overhead on sites, even though even these limits are not really reached that much usually. So what I'm trying to say here is that very often these tools are used to do a few things that are the highest impact. Like, you can imagine like changing the hero image of a site can have a big impact on the experience of users and the conversions. And it's a relatively simple thing, but hard to get it right, so they need to iterate. And a story I want to share to give you some example of why users find these values in these tools is that recently we did this feature in Google Optimize for COVID banners for sites. That would be targeted. So, as things were evolving in the space of closing businesses, different the closing rules were different from country to country or state to state or even city to city. These sites could have a solution that would let them instantly put a small banner on the site that would be targeted differently in different geolocations. That doing something like that, going through your development, process is very difficult for many of these businesses. But another thing to say here is that, yeah, clearly these tools are not always active on the site, even they are installed. What we are seeing here is that very often the businesses will do some experiments, then will try to implement those. They will go through iterations. They're not going to be active all the time. And they would prefer something that gives them the flexibility to install and uninstall these tools as they go. And that's from me, almost in time. Any questions?
Thank you. Thank you. Yeah, so one question that, yeah, one question regarding usage. You mentioned usage with the Google Tag Manager, which is due to convenience, but then adds an extra hop or two to actually loading the render blocking content. Is this something like, are the users that use GTM for that aware of the cost that convenience adds them? Or is this something they are doing without being aware of the implications?
Yeah, I mean, obviously there's going to be a range. Certainly, as Tim said, we do try to do a good job trying to, in our help documentation, even in the UI and Google Optimize, warn them against that. I suspect that what happens is that users find it like that it's better to pay a small, an extra price while they're running the experiment, if they're going to run it, say, for a week, rather than have the snippet installed on their site continuously while they're not running experiments. So there is plus and minuses there. The flexibility of adding it while doing the experiment and removing it then is probably a reason. But we do try to warn them in terms of, that they would get better performance by not going through Google Tag Manager for sure.
Okay, cool, thanks. Any other questions?
Maybe something a bit tactical, like you mentioned that sometimes people don't even run experiments for a long time, but still they have all the machinery in place. And I was wondering if maybe the script could notice that for this particular client, there is no experiment running, and therefore could respond with, I don't know if it makes sense, but like a 2 or 4, like no content, and then have a style-wide revalidate that is short enough so that you could pick up a new version when you notice that there is actually a new experiment about to run. So it might delay a bit when the experiment starts, but then you can avoid all this like runtime machinery that runs for no good reasons. I don't know what you think about that.
Yeah, I mean, there is that might make sense. We have there is some details there that have prevented us from doing that. First of all, okay, the empty container script is relatively small. It's like 20K or something. So we kind of thought, if you do the request to the server and you are going to get back something. And we do have some browser caching anyway. I guess what we could do is get a bigger browser caching if there are no experiments, but that again, would cause the users to, get more, wondering why things don't work as they expect them. Some other details is that we offer an API in the client side that, would tell you if you have experiments running or what experiments are running. Some people are implementing it themselves. They use the targeting of Optimize, but they want to do the implementation themselves. And that's probably a good story for things like SPAs or features that are not on the very first rendering path. But maybe it's an area to think more and try to improve.
Okay, thanks.
Thank you. So I think that with that, we'll take a 5-minute break and then reconvene in, let's say, 15 after the hour to talk a bit about a probably silly proposal or thought experiment that I have, and then talk about brainstorm a potential solution based off of everything we heard up until now and that. Okay, so see you all in 5 minutes or so.